All right, welcome ladies and gentlemen to week number 31. This is open Q&A. Why is it telling me that's opening? That's really weird. It should be going through there, so hopefully there's maybe just a little bit of delay. It looks like it's pulling through there. So sorry about that. Not really sure what's going on, but thank you guys for joining in tonight where I go ahead and take your questions and I go ahead and answer them. So we definitely have some great questions that I am excited to get to at the end of the stream. But I believe everybody, if you just go through the chat, it seems a little bit different for me. Just make sure that it's working good on my end. It says I have a good connection, so I'm assuming everything is working. But if you don't mind just letting me know maybe that everything might be a little bit delayed on the chat. Okay, everything sounds good. So I will roll with that and just keep on going. But I wanted to start off this chat, just kind of getting with you guys, letting you know, because I know the school year is coming along and I know many of you have kind of avoided thinking about going back into the classroom, or maybe you've already started going back to the classroom and, you know, just kind of let you guys know some things that I have taken from last year and thought about as I'm entering this year. And one of those big things has been like, how am I approaching teaching and how I plan on changing my instruction. And I think this is really actually important because one thing that it really brings into is, you know, that idea of constantly reflecting of how you can always go ahead and improve. So those are some things that I wanted to, you know, kind of get into, and I'll give you guys some a little bit specifics onto there. If you are new, well, I'll get to those in just a second, but if you are new to my live stream, just let you guys know that I will I'm going to go ahead and cover some questions at the end. These are questions that people can submit during using the Google form, which is in the description. So if you do have some questions that you would like for me to answer on my next live stream, then go ahead and check out the description and go to the Google form. You can submit it there. Also, if you have not joined my Discord group, go ahead and join there. There's a lot of people posting questions, a lot of people answering questions, and it is something that I am involved with as well. Just another way for you guys to get some help and support on your math help. And I know that, guys, as we're getting closer to the school year, that's exactly what many of you are going to want. Tonight is actually a really, really big night, guys, because it is the last night before my course is actually going live. So I know if you guys have been around on my channel, you know that I have been doing some promotions, just making sure posting on stories on Instagram, letting you guys know, especially really just for those of you that are taking pre-calculus, that I am opening up that course for opening up that course for students to join. So up until this point, it's been something that I've only had my own students inside the classroom had access to my online teaching. So it's not something that I have the videos or the resources that are available on YouTube. So that is one thing that getting into this new year, you know, my students benefited obviously last year when we had to do the teach from home. They were, you know, pretty well prepared because they were already used to having the access to my materials online. And that was something that I just, you know, figured would be beneficial to other students to really gain access to. So if that's something that interests you, then obviously stay tuned for my channel. I will be going live every day this week, just kind of answering questions and helping people decide, you know, if joining my course is going to be right for them, if it has what they need to support them throughout the year, and if it's a right fit, you know, for them. So if you are interested, then just go ahead and take a look. Again, I'll be going live every single week. And then also, I believe I have the link in the description, PC Masterclass. And also, I also have a free training, 4-week training that I've been doing over July if you are just getting back into the session. Because I know a lot of students do not think very much about pre-calculus in July. But now that we are officially in August, some of you maybe have just kind of been turning on the computer and saying, all right, let's maybe kind of look at what my schedule is, getting back to school, so on and so forth. So I did do 4-week trainings to prepare you for pre-calculus. And now I'm doing a masterclass, kind of teaching the mindset as well as some tips and tricks to be successful in pre-calculus. That's going to give you all the details for my course, which again is going to be available starting tomorrow. So if you are interested in that, go ahead and check it out. But otherwise, guys, I want to get into some things that I changed as far as the teaching, because I think this is something you guys will notice on my channel, is that I am changing a little bit as far as the videos, and I want to kind of bring this back a little bit from you guys, that the reason why I looked at our previous lessons, like when I would go ahead and teach, we had 90-minute blocks. So I could teach a lot of content, and or we could cover a lot of content. And, typically if we didn't have enough, like I would just fill in those voids, like, oh, well, here's something interesting to know. Here's something not interesting to know. And it was really kind of easy because that was just what was expected of us. But obviously with the end of last year, I didn't have the students' attention. It's like basically I had to give them what they needed to know, and I had to keep them engaged. And also I didn't want them sitting around watching an hour lecture, or we didn't have time to really break things into practice things. I needed to deliver them exactly what they needed to know in the shortest amount of time. And that was really something that I think has always been there. But the idea of the way that at least our classroom was structured, that, they had to be in my classroom for that 90 minutes. So if I only had so much to teach for that 90 minutes, well, I would just fill in that gap, like we'd just be doing something else that maybe they didn't have to know or maybe they didn't need to be doing so many of those example problems, right? It was just kind of redundant, or what we call busy work, so on and so forth. But I think now that we're getting into this hybrid model, or even teaching from home, I think it's even more important that students understand and teachers understand that, we need to not just fill in the time or make students do examples just to do examples. We want to make sure that we really look through our curriculum, identify it is what exactly we want them to know from each of these sections, chapters, however the course is structured, and give that to them in a meaningful and to a point method, and then go ahead and move on. Obviously, you want to support things, connect things, and everything else. But, I look back through my curriculum last year, and I realized there was just a lot of redundancy that I was adding. And the reason why is because I could, right? There was no reason for me. There was nothing forcing me to trim down my content. A lot of the content that I had my students, review would be like hour lectures, like 80-minute lectures. Well, no kid wants to watch 80 minutes of, me teaching some content. I mean, it's great. I enjoy teaching it and, and everything like that. But like, if you want to learn something, you want to learn exactly what you need to know quickly. And so that's the approach that I have kind of taken with my upcoming instruction. And that's what I've kind of done also in my course. And that's one of the things that I am, when I realized was with my course is, I think people can benefit from learning in that kind of format rather than saying, oh, well, here's 80 minutes of me teaching the same thing. You know what? Here's 15 minutes of me teaching exactly what you should know from this, doing multiple examples, explaining it, but not going over and about, everything from there. So that is how I'm approaching school this year. And I think from from what you guys will see in my classroom videos, which I am hoping I will still be able to do this year. But you guys will see that I'm not going to have as many of those examples, because basically I'm going to want to provide my students with a tailored kind of framework for us to get to math done. And then, my teaching is really going to be a little bit more of a supportive environment. Not so much of showing them all these examples or doing a lecture in front of the class, but, really kind of giving them exactly what they need to do, getting them started, and then supporting them. So I will still be teaching. I will still be making some videos inside the classroom, but not as many, because I think that it's time now for me to really look into the best way to deliver instruction and really refine things. And I don't think doing so many, examples or just talking to fill in a class time is going to be necessary. So that is it for that. Now we'll go and get into the open kind of Q&A portion, where I did have some mix of questions as well as some mathematical questions. So we'll kind of get into those. We talked about these kind of questions. Here's a math question talking about the domain. That was always a good one. Some more resources. We have some sequences, which I don't really like, but fortunately I was able to look at this one and I just had to pull up the formulas. It's just been so long since I did sequences and series. We have some graphing exponential equations. That's a good one. And then rationalizing the denominator. And then last but not least, we have a little Rolle's theorem and mean value theorem, which again, it's been a while, so I just wanted to make sure I wrote down some stuff to kind of cover them. So that is what we'll cover. And then depending on how long that takes me, ladies and gentlemen, if you do have some questions from your own classes, then I'll be, or just in this chat, then please feel free to add them into the live stream, and I'll be more than happy to see what I can do to go and get those answered. So let's see. Polyron, good to see you from Brazil. Awesome. Steezy, Thomas, what software tech? I will be getting to that, Thomas, in just a second. Puzzle Master, that is a great approach for your current circumstances. Very good. Thank you. Timothy Jones says masculinity is unpressing pre-calc. Well, awesome, Timothy. Timothy. I don't know why I called you Timmy. I am so happy. And hello, Alexa, Adrian, Saim, awesome. Arsena from Florida too, but I'm in Sarasota. Well, awesome. Good to see you. Another Floridian. All right. So let's go ahead and get into this. So what is my first question? Oh, I already got to that. Yes. All right. All right. Viv Sot, what grade is pre-calculus taught and what skills are taught? So there's a couple things that I have to kind of address this. So obviously pre-calculus is a course that typically students learn in their, in like high school or in college, university. And, you know, in my school, typically I have students that are in the 10th, 11th, or 12th grade. I took it when I was in high school. I took it as a 12th grader. But I also took it in college as well because I did not do as well when I was in high school. So I had to retake the course. And obviously it's kind of important if you want to be a math teacher to do well in pre-calculus. So, but I would say typically in my class is we have a honors pre-calculus course. So typically I have a lot of 10th and 11th graders. However, I would say that there is definitely, that does concern me a little bit. I think there should be more 11th and 12th graders kind of portion to there. I think just in our school, or at least in our district, there's a big push for the honors, you know, curriculum and everybody kind of being pushed through there. And a lot of the students that do enter my classroom are not really prepared, especially in 10th grade. They're not prepared for the course. They're not prepared for the rigor and the type of questioning. And they would benefit if they would take it another, you know, as an 11th grader or a 12th grader. And they'd be more successful if they did that. And the problem is they take it so early, they get frustrated, they're not prepared for it, and then they struggle, and it's not good. So I hope that, you know, one of the things that we can look at is kind of restruggling there. But, you know, I would say anywhere, a lot of students come in from the 10th through 12th. So I guess it really kind of depends on your school, the program you're in, and what you're really trying to achieve. But, you know, one thing I tell students, I mean, I have a math degree and I took pre-calculus in senior year and I took it again in college. So, you know, it's not a race, and, you know, it really kind of depends on, do you understand the material and what can you master? And you can definitely take it earlier, right, Brian? I mean, cheers to you. That's awesome. There is no limit, guys. There is no rule that you have to take it at a certain level. You know, I mean, if you understand the material, you understand what you're supposed to know ahead of time, then take it as a 5th grader, an 8th grader. Like, it doesn't matter. There's no rules of when you have to take the course. It really kind of depends on how well your foundational skills are entering through pre-calculus, because pre-calculus is a little bit of the gateway into the upper level mathematics. In terms of the skills that are really taught in pre-calculus, I kind of treat it as like a triangle. You kind of have the algebra 2, you know, functions, polynomials, rational functions. Then you have the trigonometry. So, you know, just basic trig, oblique triangles, law of sines, law of cosines. You have analytic geometry, and you also have the identities and all that kind of stuff. Analytic geometry as well as analytic trigonometry. And then you also have just calculus, like calculus topics, sequences and series. We get into polar and parametric. So just things that will help you prepare you for the calculus. So kind of a 3-part: algebra, trig, and then calculus topics. At All Time Mathematics, ATM says, what software do you use? So when I am doing my live streams, like I'm with you guys right now, I am using ScreenFlow, which is a app on my Mac. And then I'm also using, what am I using? I forget what it is. Oh, and then I'm using Ecamm. So I'm using Ecamm as my software to stream, and then I'm using Notability app to go ahead and post that on my wall so you guys can see that. Well, yes, you're posting a lot of stuff in here. Yes, thank you, Timothy. That is very, very good. And yes, that is very close to, where are you getting all this, Timothy? Someone asked what, oh, from my university. Yeah, very good. I like it. That's definitely pretty close to everything that I cover as well. Thank you for that. All right, so now let's get into some topics. So let's go ahead and talk about the domain of secant, cosecant, cotangent. This was presented from Mega Mathis. All right, so this is actually kind of a big question. So I don't want to spend too much time on this because this is literally like a whole lecture that we'll cover from this. So let's just kind of do a quick little review of where secant, cosecant, and cotangent go from. Let's talk about the secant graph. So let's go ahead and quickly do the cosine graph, because hopefully you recognize that the cosine graph and the secant graph are what we call reciprocals of each other. I'm sorry. Yes, they are reciprocals of each other. So that is the cosine graph, but that is not what we're graphing, right? We are graphing the secant graph. So the important thing is, if you understand about the reciprocal functions, is that, remember, like the coordinate points, like these are the points, and you can find these points on the unit circle. But whenever my cosine is going to be equal to 0, so for instance, this is at 0, this would be at 90 degrees, right? So we're at pi halves. Well, at pi halves on the coordinate point, that is 1, 0. Well, if you take the reciprocal of that, that'd be 1 over 0. And therefore, or I'm sorry, at cosine, I'm doing horrible on my explanation. You can see on cosine, in this case, is 0, right? The output value is 0. So if you're looking at secant, the reciprocal of that is 1 over 0, which is what we're going to call a undefined value, or a vertical asymptote. So the relationship between cosine and secant, and again, this isn't about the problem. What the student was asking was not so much what the graph looks like, but what is the domain? So I just want to explain this here real quick, because basically the secant graph and the cosecant graph, they have their asymptotes, or they are undefined when cosine or sine is equal to 0, right? Because they're the reciprocal. Like if you have 0, then the reciprocal is going to be 1 over 0, which is undefined. So basically we need to be able to identify is where these asymptotes occur. So the domain for secant of x, so the domain is basically going to be all real numbers except for where these asymptotes occur. Now, one thing we do recognize about the cosine graph is that it has a period of 2 pi. And if you look at this, it looks like each of these asymptotes is not occurring every 2 pi, but it looks like it's occurring every pi, and that is the case. So basically, we need to identify where they occur, and this first thing you could say, that's at pi halves. This would be at negative pi halves. So the domain, a couple ways you can write this, is going to be all real numbers such that x cannot equal, and let's just kind of pick one asymptote here, which would be pi halves. And then you can see, though, that the distance between each asymptote is the same, right? So you could say, well, it could be plus pi, it could be plus 2 pi, it could be plus 3 pi, right? You can just keep on adding pi, or you could keep on subtracting pi. Well, how many times could you add or subtract pi? And there's actually infinite many. So that's why we use the integer n. You could use k, you could use c, but we'll just say plus pi n, where n represents an integer. So if you're adding, n is positive. If you're subtracting pi, n would be negative. And again, if n was 0, you would have pi halves, which again is undefined. So hopefully that gave you a understanding. Let's go ahead and look at the sine graph to see how sine relates. And then we'll look at cotangent, because I said I would. All right, sine is very similar. Sine graph looks something like this, right? Wow, what the heck is going on? Let's do that again. Okay, so here's the sine graph. Okay, and again, if we're looking for when is the asymptotes going to occur, they're going to occur for cosecant when sine crosses the x-axis. Okay, now let's maybe identify where this would be. If you think about like the unit circle, you can see at 0 and not at pi halves. That would be when the y-coordinate would be 1, but at pi, it's going to be at 0 again. So if we're looking at this, we say, all right, well, what about y equals cosecant of x? So that looks like that is now going to occur at, let's see, let's just call the asymptotes. So let's just find the equation of the asymptotes. I didn't do that in here, which I probably should have. So the asymptotes are going to be y equals pi halves plus pi n. All right, so here we have the asymptotes. Let's just pick again an asymptote. Let's pick 0. So 0 plus, and again, it looks like from here to here is a period, right? That's 2 pi. It looks like the asymptote occurs halfway. So that'd be pi n. And again, guys, we don't really need to write 0 plus pi n. We can just write pi n. So the domain is going to be all real numbers such that x cannot equal pi n, right? Because again, it's basically every pi adding to it. All right, now let's just go and get onto the last example, which is the cotangent graph. And if I remember, I do remember, cotangent is going to look like this. Okay. And then it's just going to keep on repeating itself. Now, the main thing is we got to remember, well, when is cotangent? When is it undefined? Like, where are these asymptotes? How do I know where those asymptotes are? And I think the easiest thing to do is think about again, going back to the unit circle. Remember, the cotangent of an angle is going to be the x-coordinate over the y-coordinate. Okay? So if we look at these coordinate points, this is 1, 0. This is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. So again, starting at 0, you can see that the y over the x is undefined, right? Over here, the x over the y, 0 over 1 is 0. And then over here, you can see that x over 0 or negative 1 over 0 is undefined. So this would be pi. It has a x-intercept at pi halves, which I believe the student also was asking about the x-intercepts. Now, the important thing for the cosecant and the secant graph is those do not have any x-intercepts unless the graph is being transformed. But just in its parent graph, it does not have any x-intercepts. But this graph definitely has an x-intercept at pi halves, asymptotes every pi n. So it's actually just going to be the exact same, as you can see here, because that would cross at pi as well. It's actually just going to have the exact same domain as sine. So the domain here is going to be all real numbers such that x cannot equal pi n. So there you go, Mega Maths. Hopefully that helped, or Mathis, hopefully that helped you out. There we go. All right. Hi, Ultimate Charles Gamer. How are you? Adrian, thank you very much, guys, for joining in. All right. So let's go ahead and get into geometry, basic algebra. Yes. All right. D says, what resources do you recommend for success in pre-calculus? Kind of a funny question. I swear I did not plant this question. It's literally on the Google Doc. Somebody supported it. But I would definitely recommend my YouTube channel as well as my course that is going live tomorrow. Obviously, there's a lot of other resources as far as for success in pre-calculus. So, you know, obviously besides everything that I do, I've been teaching pre-calculus for over 10 years now. So I feel pretty comfortable with the content, but again, I don't cover everything that everybody has in their own pre-calculus class. So I would definitely say that, you want to have some other videos or, websites available to you. And I think some of the standard, just standard, any kind of like, making sure that you know how to check answers, like knowing what the questions are, the graphing questions, I think Slater.com is very helpful just to be able to see answers in different textbooks, even if you don't have your own textbook. Like I don't teach from a textbook anymore, but there's a lot. When I used to teach from a textbook, I would use Slater. I would have my students check their work in Slater.com, and you can just learn from Slater.com, by looking at all that work. So I think that's definitely something is very helpful. And then I do have some other websites and some other things that I'll be covering in my masterclass. So for all the people that are signed up for there, I'm just going to kind of hold those off. And also, obviously, I'm teaching pre-calculus this year. And so if that is something that is interest of you, you can join the masterclass and then check it out and see if it's something of interest to you. But I would definitely say that as far as on a pre-calculus, I'm trying to think. There's yeah, I can't remember. As far as on the resources, I think I would definitely just check out Slater.com. I think that's been pretty good. And Mathway. Mathway is something that I use. Well, I guess the three that I would say I've used, just to kind of give you some websites, Mathway, Desmos, and Slater have been some math stuff that I've used definitely from there. And again, I have no promotion or anything else to those three websites. Theirs are just used, but I am keeping still some for my masterclass. So if you guys are interested as far as a couple more hidden gems, I have those for you guys as well. All right. The next one, ace of n, ace of 20, and s of 20. That is going to be the sum. So the student gave me three numbers, -3, 3, and 10. And what they want us to do is find the general rule, the value of the sequence for the 20th value, or the value of the 20th term, and then the sum from all the way up through the 20th term. So for the general rule of a sequence, we have ace of n equals ace of 1 plus the common difference times n minus 1. And then we have the sum for those up to that 10th term is going to be n times ace of 1 plus ace of n divided by 2. So when we're finding the equation, right, now typically the student didn't tell me what type of expression we were looking for, but typically you're going to be looking for arithmetic or a geometric sequence. And obviously if it's neither one of those, then you'll have to do a little bit more workaround to be able to identify what the general equation is. But if you're able to understand a common difference or a common ratio, it makes things a little bit easier. You have this nice little formula now that we can kind of go off of. So that's why we like to focus on those arithmetic and geometric sequences so that you guys can kind of follow with the rules. So in this case, if you want to find the common difference here, we see that, 3 minus a -4 is equal to 10 minus 3. So our common difference here is 7. All right, so that is going to be our common difference, 7. We have ace of 1, which is -4. And ace of n is going to that's what we're going to use from there. So we'll just say ace of n, that represents any number in the term. So that's going to be -4 plus 7 times n minus 1. Apply a little distributive property. 7n minus 7. And therefore, our general rule for this form is going to be 7n minus 11. The next thing, if I want to find the 20th term, all I'm simply going to do is plug in 20. So if I want to find ace of 20, then I'm just going to plug 20 in for n. So it'll be 7 times 20 minus 11. So 7 times 20, 7 times 2 is 14. So 7 times 20 is going to be 140 minus 11, which is equal to 129. So that's going to be your 20th term. And then our sum from the 20th term is s of 20. Again, we have 20 terms, so you're just going to do 20. That's going to be your number of terms. And then just going to do ace of 1. Ace of 1, which is -4. Plus the ace of 20th term. So that's going to be your 20th term here, which we figured out to be 129. All over 2. Now, I don't have a calculator, so I'm just going to leave it at that. But those are going to be at least your two formulas you will want to figure out. All right. And I just see a quick little question on that. Desmos, what is the class tomorrow going live? Sorry, I just seen some of these. Can we submit questions? Do you like geometry? Yes, I love teaching geometry. I'm not teaching it though. Mathway is awesome. There's can you submit questions? I'm not sure what that means. You can submit questions now, but I'm not going to be answering questions until I am done, which I have 2 more questions. And then I'll take some of your questions for that. A graphing calculator. Typically, most pre-calculus courses, I would say, require a graphing technology. I only require it for my students for 1 course or for 1 chapter. Everything else I really manage to deal with is without using a graphing calculator. Emmanuel, you have Desmos spelled correctly. And when is the class tomorrow going live? So I am going live tomorrow at 3 p.m. I will put in the notes, I'll put down the schedule. It should be all saved on my channel. But if not, if I can remember correctly, tomorrow I am going live at 3 p.m. Tuesday, I am going live at 11 a.m. Wednesday, 9 p.m. Thursday, 3 p.m. Friday, 11 a.m. So I will be going to live a lot. And again, this is really just mostly for the pre-calc students. I'm not doing open Q&A or anything like that. I'm just going to be kind of addressing some questions. And so if you guys have some questions, I do have a Google form that you can pre-submit questions inside of the chat ahead of time. So therefore I can review and, make sure that I have time to address all of the questions. Or you can just always show up live and then ask from there. TNI is a good investment. Yes, I'd highly recommend if you're taking more than 1 math class, like pre-calculus is not like your last math class, then I would recommend investing in a graphing calculator. Can you do videos on linear algebra? Absolutely, I can. I cannot wait to start doing some more types of videos. At the moment, I am just focused on working on my pre-calculus, and so I don't have any linear algebra videos, but that is definitely something that I want to continue working on. So, do you make your students memorize the unit circle? No, I do not make them memorize the unit circle, but they do have to memorize the first quadrant. So, that is something that I have another video I'm looking forward to doing, or at least redoing. But no, I do not believe in memorizing the unit circle, but definitely they need to make sure they know how to memorize the first quadrant. So, let me go and finish my 2 math. Thank you for the nice little break though. And then I will get back into the chat. So, let's go and talk about the exponential functions. So if we need to graph exponential functions, one thing we need to understand. First, we need to understand the parent graph. I'll get your guys' questions just a second. Y equals e to the x. That graph looks like this. Something like that. Horizontal asymptote, and it has a y-intercept at 0, 1. Okay, horizontal asymptote at y equals 0. So in this case, basically all we need to do then is just understand the transformations. Now, when I distribute this, we cannot take 1/2 of 2 because that 2 is being raised to a power. So we have a 1/2 times 2 to the x minus, we can multiply the 1/2 times the 8 though, which would be 4. So now we need to understand all of our different transformations. All right, so we have a transformation. So we have base 2 to the x, which it'd be the same thing as e to the x. It is going to change the growth pattern. But if I was to graph y equals 2 to the x, y equals e to the x, they're going to be very, very similar to y equals e to the x. All right. But the 1/2 makes a big difference. Instead of it crossing at 0, 1, now my graph is going to have a y-intercept of 0, 1/2. So the 1/2 is a vertical compression. And then we're also taking the graph and shifting it down 4 units. So instead of having a y horizontal asymptote at -4 at 0, it's now going to be at -1, 2, 3, 4. Okay. And then again, you can just take this point and say that's going to only be 1/2 from the asymptote. And then your graph would look something like that. The next example is, again, going to be very similar. I'm not worried about the 3 to the x. That's going to be very similar as 2 to the x or e to the x. I am concerned about the negative, which is a reflection about the x-axis. So instead of the graph going up, it's now going to be going down. It's now, instead of having a vertical compression of 1/2, now it's going to have a vertical stretch of 2. So instead of it crossing at 0, 1, now it crosses at 0, 2. But again, it's reflected, right? So it's actually going down. And then the graph is being shifted up 5 units. So instead of the horizontal asymptote being at 0, it's actually up 1, 2, 3, 4, 5. And then again, remember the y-intercept was down 2 units. So asymptotes, and then down 2 units, it's reflecting down. So the graph would look probably something like that, hopefully. All right. Oh, I actually still have 2 more questions. Sorry about that. And then I'll get into yours for you guys. Sorry about that. I think everything's going good for me on there. Yeah, it says my connection is all fine. But let me know, guys, if there's any other issues you guys have for that. All right, so the next one is simplify the rational expression. So I have 2 square root of 7 plus 3 square root of 3. So when we want to simplify a rational expression, we basically are looking to getting rid of the radical. And to get rid of the radical, what we want to do is create, at least when we have a binomial, is to creating the difference of 2 squares. Because if you create the difference of 2 squares, when you have these binomials here, that's going to create the first term squared minus the second term squared. Well, what's great about having the first term squared and the second term squared? They get rid of the radicals, or they square the square roots. Square the square roots undoes the square root. So let's go ahead and figure out what the conjugate then would be for 2 square root of 7 plus 3 square root of 3. That's going to be 2 square root of 7 minus 3 square root of 3. 2 square root of 7 minus 3 square root of 3. Okay, now in the numerator, we can just distribute that, right? In the denominator here, again, it's just the difference of 2 squares. It's as simple as this, right? So yes, you could distribute both, do FOIL, whatever you want to do, box method, perfectly fine. But in reality, it's really just this times this minus this times that. So let's go and see what that would be. Remember, when you're multiplying radicals, you multiply the coefficients together, and then you multiply the radicands. So you're going to have 2 times 2, which is 4. And then 5 times 7, which is square root of 35, right? 5 times 7 is 35, but it's still under the square root. Minus, let's see, that's going to be 6, square root of 15. Then in the denominator here, I'm going to have 7 or 4. I'll just write that like this, times 49, right? Kind of following the same steps. And then this is going to be 9 square root of 9. Okay. Now, when you're simplifying radicals, you always want to see, is there any square number that you can divide into to make it simplified? And this numerator is going to be pretty much as it is. So there's nothing we're going to be able to do here. Down here, obviously the square root of 49 is 7. 4 times 7 is 28. Square root of 9 is 3. Negative 9 times 3 is going to be a 27. So obviously you can see that that becomes 1. So my final answer is 4 square root of 35 minus 6 square root of 15. All right. So let's go and get on to the last example, which is Rolle's theorem versus the mean value theorem. Really the main thing that I wanted to kind of bring up with this is I think once you kind of see them in terms of a graph, they kind of make a little bit more sense because they are pretty simple theorems. If you read the mathematical theorem, though, they can be confusing, right? And they're related to each other. And really, Rolle's theorem is just a more specific portion of the mean value theorem. So you can see how they're very, very similar to each other. The main thing, though, I'd like for you to take away from this is that these are what we call existence theorems. So when you have the conditions, when the conditions meet for Rolle's theorem or mean value theorem, it doesn't tell you, when something is occurring or what the value is. It just tells you that something does exist. So for the mean value theorem and for the Rolle's theorem, we have to make sure that we have an interval or a function that is continuous on a closed interval from a to b. It has to be differentiable. That means you can find the derivative on the interval a to b. And for Rolle's theorem, you also have to have that f of a is equal to f of b. I forgot to write that in there. But this is very important. From f of a has to equal f of b. What that means is basically the endpoints need to have the exact same. Now, it doesn't always occur, but let's just think about it. When you see a function where f of a is equal to f of b, and it's a closed interval and it's differentiable, just think Rolle's theorem. I'm not saying it's going to occur or you're going to use it, but it's usually a pretty good kind of tip that is possibility. So what Rolle's theorem basically says is if you have a function that meets those, closed, it's continuous, differentiable, then there has to exist a value C where the derivative or the tangent line is going to equal to 0. Basically, if you have a function that is continuous, right, and differentiable on these closed intervals, and they have the same initial and terminal like value, then there has to exist basically a tangent line that is horizontal. Has to exist. Now, in this case, we actually have 3 of them, right? But all it's saying is there has to be one, because even if I did a correct line, right, that'd be the shortest path between those 2 points. That again is a tangent line, right? So no matter what you do, scroll, there has to at least be one point that's going to be the tangent line. Now, the mean value theorem is basically kind of the same thing. The mean value theorem, though, has the same conditions, but the f of A does not have to equal f of B. It doesn't have to be bigger or smaller. But basically what this theorem is telling us is that this secant line, that whenever you have the values that match up for the mean value theorem, that you have to have a tangent line that is going to equal the secant line. Now, again, in this case, it looks like I have 2 tangent lines that have the same slope or the value of my secant line. But again, all it's saying is, because again, if you were to draw a straight line from here to here, that would be your secant as well as your tangent line. They would equal each other. So it doesn't matter what up and down you go, that you're still going to go ahead and match them up. All right. Yes, you can rationalize the denominator. You can rationalize the numerator. You can do a whole bunch of things. And yeah, and obviously once we get into calculus, rationalizing the numerator becomes a little bit more important than previous what we've had. All right, guys, that is pretty it. If you guys have any other additional kind of questions or anything else that maybe I didn't cover, I do have a couple more minutes. I'm not sure how many more problems, but a couple more minutes to maybe answer any other questions you guys have. Has anybody started school? I'm just kind of curious if anybody's actually back yet in the classroom, or if anybody is starting in the next couple weeks like I am. Our school is starting on the 20th. And I know a lot of schools also got pushed to September. So I'm just kind of interested to see what you guys are doing. Call my Midwest time, Eastern time, China time. Yes, all of my times, Emmanuel, are in Eastern time. So I will make sure that I put my schedule. Actually, you know what? Let me see. No, crap, it's in that email. But I'll make sure I put in that in the description. So therefore, anybody else that maybe is watching the replay, or if you want to come back to this later, I will have the description updated so you can see it in there. And yes, for these live streams that are going on this week, guys, if you have some questions, I'm not doing math problems submitted like here, where you guys can submit your math problems and then I'll post them. But obviously, if you have a question and we're on a chat, I'm happy to help you guys out from there. Start school in 2 months. Wow. I'm starting school tomorrow. Well, very good luck, Aiden. Johnny V, does military schooling count? Yes, of course it does. Well, hello, John. Good to have you on. The UK. Okay. Very interesting. Yeah, interesting to kind of see how everybody is approaching this going back to school. You already hear like people going back to school. There's already been infections, and I don't know. It looks crazy. 1 month. Wow. Can you do videos on intuition needed to make mathematical relationships like cases of the derivative? Those are very, very good, Caleb. I'd probably say the time and attention that you need to make those videos is a lot. And I've thought about doing something like that. And it's, I don't know. I mean, since I'm still teaching, it's very difficult to, not only do my channel, everything I do for that, making videos, but also to teach, grade, cook dinner. So those videos, the people that do those videos on YouTube, they are a lot of like the really good ones are amazing because they put in a lot of time into those. And obviously that is something that I just do not have, but I do appreciate everybody that has helped me get to where I am at, especially with some of my newer videos, because after I am done closing the doors on my pre-calculus course, I'm looking forward to, again, creating some more videos for my channel. And then obviously once I get back into school, I'll be doing that. And everybody that is joining me on my memberships in YouTube, they have been a huge support and helped me develop my new content. Who do you have in the NHL playoffs? Johnny V, the Red Wings, man. Seriously, come on, the Red Wings. Well, thank you very much, guys. All right, guys. Well, that is School Starts 20 days. Wow. Good luck. You got it. All right, guys. Well, I am going to sign off for tonight. I have a masterclass tomorrow at the same time. If you're taking pre-calculus and you're interested, make sure you guys go to that description. PC Masterclass and go and get yourself signed up. I do have some tips. You don't even have to actually want the course. You can actually just take my tips and enjoy that. That is totally free. Then I'll also be going live tomorrow at 3 p.m. Eastern Standard Time and for the rest of this week. So if you guys want to join me, I'm doing different times. I'm doing 11, I'm doing 3, I'm doing 9. I am just basically going live as much as I possibly can because my course is only going to be open for 2 weeks. And then I am closing it down and I am focusing back on being a teacher inside the classroom, as well as my YouTube channel and helping the students inside of my course. So thank you so much, guys, for Thank you so much, guys, for joining me on this live stream tonight. And hopefully I will see you in another one this upcoming week. All right, guys, peace out. And I forgot to put that in.